Hey everybody, in this AP Chem series video, we're going to take a look at pH and its closely related but completely opposite cousin, POH. First, remember from the last video we saw that pH is really just a simplified way of stating the H3O plus concentration in an aqueous solution that of course tells us if that solution is acidic or basic. Here's the formula where you can see we're just taking the negative log of the H3O plus or the H plus depending on how you want to write it. If the solution is acidic, that means the H3O plus is greater than the hydroxide concentration, and we're going to land somewhere between 0 and 7. If it's a base, then the H3O plus concentration is less than the hydroxide, and we're going to land somewhere between 7 and 14. So now let's take a look at some other pH scale equations. Just like we take the negative log of H plus or H3O plus to get the pH, you can also take the negative log of that hydroxide ion concentration for any acid or base solution as well. If you do that, you'll get an answer that looks a whole lot like pH, but we can't call it pH because it's not the negative log of the H3O plus. So instead, we call it the POH value. And this gives rise to a whole other new scale called the POH scale that works exactly like the pH one except in reverse. Here's an example of the two scales laid side by side. This helps to highlight the fact that on a pH range of, let's say, 7 to 14, those would be our alkaline or basic pHs. Those same base solutions on the POH scale would be the opposite, falling within a range of instead 0 to 7. Or this pitcher of lemonade, for example, that has an H3O plus concentration of 6.6 times 10 to the minus 2 m. If I take the negative log of that, it's going to tell me that the pH of my lemonade is somewhere between 1 and 2. Clearly this is an acidic solution, which we already knew because it's lemonade. If I knew the hydroxide concentration in that lemonade is 1.5 times 10 to the minus 13, so it's much less, and I took the negative log of that, I'd get a POH that is up somewhere between 12 and 13. So by looking at the pH, I know that my lemonade is acidic because the pH is between 0 and 7. But looking at the POH, I know it's acidic as well, except acid solutions on the POH scale will fall between 7 and 14. The POH equation and these overlapping scales are some of the key ideas for this video. Make sure to pause and take some time to write those down. We also have one final extremely useful equation that now relates the pH to the POH of any acid or base solution. The pH and the POH values are always related by this formula. If you add them together, they will always add up to 14. You can see that here with the lemonade example. If the pH of the lemonade is about 2 and the POH is about 12, 2 plus 12 is 14. This formula is another key idea for the video. Make sure to pause, take some time, and write that down. That also wraps it up for this video on pH and POH. Thanks a lot for watching, and here is a brief summary.